A chapter on extensibility and SIP services in deployed networks would be incomplete without a mention of the IMS. In this lesson, we'll briefly introduce the IP multimedia subsystem. It will be brief as there's so much to discuss. We've included a series of more detailed lessons in a dedicated IMS chapter later in the course. Back in the 90s, the mobile operators were realizing the limitations of their 2G networks. They wanted liberation, freedom from the constraints of 2G. The 2G network didn't support true multimedia communications. They wanted it. The network was not inherently scalable or extensible. They wanted inherent scale and extensibility. Because of vendor incompatibility, the carriers were locked to their chosen manufacturer for equipment and for features. Accordingly, new features took time to build and were expensive and therefore a risk. Operators wanted freedom from vendor lock-in and the ability to easily deploy new features. The IP multimedia subsystem was born, a third-generation network, 3G, to replace 2G. It's a reference architecture in which key functions are separated into individual components, each with well-defined characteristics and well-defined interfaces through which they interact. Manufacturers build their implementations according to the spec, then compete for sales. Competition, of course, drives down prices, reducing the operator's costs, and with components built to a defined spec, enable operators to pick and mix equipment from different manufacturers, removing vendor lock-in. The IMS is IP-based from end to end, meaning the network has all the flexibility of data exchange found in any IP network. Audio, video, desktop sharing, gaming, whiteboarding, shared applications, and anything else anyone invents in the future. Being end-to-end IP, the natural choice for signaling was, of course, SIP. The IMS uses SIP for session establishment. Now, IMS components can be grouped in three main categories, including three main SIP servers, or call service control functions as they're known, that between them handle registration, authentication, feature routing, call routing, and more. There's a centralized home subscriber server, a data repository that includes the SIP registry as well as user profiles for each subscriber. And there's a place for any number of SIP application servers that apply features to calls. Imagine Dave, traveling abroad, makes a call to Nath. His SIP invite passes over radio to the roaming network's proxy CSCF. The roaming proxy CSCF looks up Dave's home network and routes the request there, specifically to the home network interrogating CSCF. In turn, after looking up details on the HSS repository, the ICSCF routes the request to an instance of the main SIP server, the serving CSCF. Now, the SCSCF does two key things. First, it manages features. Applying the half-call model, it retrieves from Dave's user profile his list of originating features, each one defined in an initial filter criteria, or IFC, then routes to all the matching feature servers one by one until all of Dave's originating features are applied. It then turns its attention to the callee, switching to terminating mode. If Nathan belongs to the same network, and we'll assume for now he does, the serving CSCF retrieves his IFCs from his user profile and routes the invite to the feature servers that serve his matching terminating features. Secondly, it applies any SIP location or dial plan routing rules and routes the invite downstream. Because each feature is a separate entity, not bound to any dedicated equipment from any particular vendor, new applications, new features can be added in with great ease and little cost. Now, you might be surprised to hear, especially knowing the IMS is a next-generation mobile network, one of its key objectives is to be independent of access type and device type. Accordingly, the IMS can be accessed from any device through mobile cellular or through everyday Wi-Fi, LAN or cable access to the internet. After all that, IMS is not just for mobile. Okay, one last point. Studying IMS architecture, you might have felt a little déjà vu. Haven't we already seen the separation of session management and routing, feature application, and border control in the enterprise network? We have. The truth is, though, the IMS thought of it first. Being a reference architecture, other networks, including enterprise networks, referred to it and, in their own way, implemented the best bits. So, in brief, the IMS is a third-generation mobile network to replace the 2G network. In fact, as we speak, 3G networks are being upgraded to faster 4G LTE networks. The good news is 4G is still IMS. IMS uses end-to-end IP, making it truly a multimedia network capable of voice, video, and any other type of application data exchange. Of most interest to us SIP enthusiasts, the IMS exclusively uses SIP as its signaling protocol. Many IMS components are SIP servers with additional or perhaps more defined capabilities built on top. The IMS has a central data repository that acts as SIP registry and that holds user profiles, and it's accessible from any IMS component, meaning they can all read and write data to and from a common repository. Features are applied by separate application servers. Each subscriber has a custom set of IFCs that define which features are applied to his originating and to his terminating calls, and under which conditions. Even though it's primarily a mobile network, the IMS is accessible by any IP-enabled device over any form of internet access, whether it be radio over cellular, Wi-Fi or fixed line, such as LAN or cable.